January 1958. The United States celebrates its victories over the Soviet Union in space. It launched not just the first artificial satellite into low Earth orbit, but also in rapid succession several other firsts, one of which being the discovery of what is now known as the Van Allen radiation belts, named after Dr. Van Allen of the Jet Propulsion Laboratory, who made the discovery. President Dwight D. Eisenhower, in his State of the Union address, says, "With the success of the American space program over the Soviet Union, we have shown the world that the United States and all the peace-loving, God-fearing people of the world will always stand stronger than the atheistic imperials that is the Soviet Union. Because this new frontier is one that has not yet seen the horrors of war, I will take the charge to ensure that it is not because of the United States that war comes to space. The United States must lead the world in the peaceful exploration of space, and through that exploration, mankind then will see more clearly than ever that the future belongs not to the concept of the regimented atheistic state, but the people, the God-fearing people, peace-loving people of the world." At the same time as Eisenhower's speech, another Aethra 2 rocket with the Pleiades 4 satellite was rolled out to the launch pad, its primary mission to finally complete the solar-powered satellite test. Welcome back to Astra. We're going to jump right in to launching our first Pleiades satellite in January of 1958. And in this one, we're finally going to finish all of the requirements in order to complete the solar-powered satellite contract. I'm going to be honest, I don't know what the date was that I launched this rocket on. I forgot. I usually click in the top right corner to set it to the local date, and I forgot to do that. But I know it's in January. It would look like, although you'll see later in this video that this is not true, that we have ended the tyranny of the early AJ-10 as this engine successfully lights and pushes our apoapsis up above the required 300 kilometers. So as the AJ-10 burns out, I'm able to use the Space Bee, which is getting a ton of use in my early space program. Right now I'm actually planning out some of my first lunar missions coming up in the next episode. And it's a good bet that we could see Space Bees being used in that. But with a good ignition of that Space Bee, I will watch as our periapsis gets higher and higher. Eventually, it shows itself above 300 kilometers. And with that, we're able to detach the satellite from the Aerobee kick stage, and it's in orbit. Now all we have to do is wait for 2 weeks and see if we have electric charge, which, spoiler warning, we do. With the success of Pleiades 4, the final stage to complete our early satellites light program can begin, and then we can eventually move our space program into its next phase. To this end, on the 10th of March in 1958, Pleiades 5 was moved out to the launch pad. While Pleiades 4 was very much the same satellite as Pleiades 1, 5 had some new experiments on board meant to allow us to gather new experimental data. The primary one was a magnetometer boom to perform tests to better understand the Earth's magnetosphere and the magnetic field. And we added a barometer and a thermometer to perform experiments on the exosphere and understand the true limits of the atmosphere. This launch goes pretty okay, but failure of the early AJ-10 causes the vehicle to not quite reach its required orbit. I attempt to push the vehicle beyond its required periapsis by waiting to release the kick stage till we're a little closer to apoapsis, but I fired it while facing in the wrong direction and put the satellite into a suborbital trajectory. This makes Pleiades 5 a failure. The 9th of May, 1958. We now have a second chance at the mission of Pleiades 5. In order to complete the atmospheric analysis satellite and complete the early satellites light missions, we need to have an apoapsis above 690 kilometers and a periapsis above 290 kilometers. Because the Aethra rocket has not failed us, I want to try and get as much out of these rockets before we have to start swapping to other launch vehicles, especially since we can get our payloads almost out to the moon with the basic Aethra rocket. Some upgrades that I definitely need to make as we get further and further into our program is replacing that early AJ-10. The only reason I haven't is because it has just the right amount of thrust-to-weight ratio for the payloads I'm launching and a nice long burn time. I would like to replace it with something with multiple relights, and my current plan is to replace it with an Agena engine for future upgraded stages. But at the moment, I'm not launching heavy enough payloads to justify retooling the tanks and avionics. As you can see, The mission is a success, and the atmospheric analysis satellite has successfully reached its required orbit, and we can deploy the experiments. First, giving our thermometer and barometer data down to Earth for the boys in the lab, and then deploying that magnetometer boom to begin getting some more science to unlock new tech. With the success of Pleiades 6, we could officially end the Pleiades program and the early satellites program. As we get into the middle of 1958, we continue our aircraft research program. McDonnell Douglas has loaned the NACA an early model of the F-4 Phantom to use for supersonic testing. On this first flight, Ben and Stan take the aircraft out above Mach 1, just off the coast of Florida. Ben and Stan noticed that one big difference between flying this and the X-3 is landing. Because the X-3 landed with empty fuel tanks, it was much lighter and had a much better glide ratio. Ben and Stan noticed that the aircraft truly does not want to fly slowly because of how heavy it is, to the point that they have to land at much higher speeds than either pilot is comfortable with. Ben quips that this is clearly an aircraft designed for Navy pilots because they probably aren't used to landing properly. Here we can see my actual face while trying to land this thing. NACA decides to not use the XF-4 again and continue testing with another aircraft. June 7th, 1958. Tragedy strikes the coast of Florida. McDonnell Douglas loans NACA a modified F-101 Voodoo to continue with the supersonic testing. Once again, Ben and Stan take to the skies with the goal of getting the aircraft closer to the Mach 2 barrier for the sustained Mach 2 testing the NACA wants to perform for the upcoming X-15 hypersonic vehicle. While the aircraft handles well over the Atlantic Ocean, once again on the landing, Ben and Stan discover that these new Century fighters do not like to fly slow. Flirting with stalling, Ben attempts to bring the aircraft into land, but the terrible glide ratio of the aircraft that Ben is not used to and the slow spool-up time of the engines proves fatal. Ben comes in too slow and low and collides with the end of the runway. He and Stan are killed instantly on impact. An investigation into the cause of the accident begins, but the NACA and FAA find no fault in the aircraft or its systems. Ben just did not have enough time to prepare and was unaware of the unique handling characteristics of the aircraft. As a result, the mission ended with the loss of both pilots. Future plans for the supersonic flight program are put on hold while new pilots are trained and new aircraft are ordered. The 26th of July, 1958, another Aethra-2 rocket is rolled out to the pad carrying the final of the Pleiades satellites on board. Its main mission is to continue the study of the Earth's magnetic field from space, while at the same time attempting to reach the first sun-synchronous orbit. The rocket races off the pad with the help of the 4 Castor 1 boosters, making its way towards the desired orbit. Unfortunately, a failure on the Aerobee upper stage causes the satellite to not reach the sun-synchronous orbit desired. The satellite is able to be deployed regardless and is able to complete its primary mission of studying the magnetic field in this highly inclined orbit. The 29th of July, 1958, President Dwight D. Eisenhower signs the National Space Act. This act moves all government space research programs under one roof, from military to civilian. It founds a new dedicated air and space agency with an administrator who reports directly to the president. The NACA is disbanded and reformed under the new National Aeronautics and Space Administration, or NASA. The president sets out 3 major goals for the new space program. 1. Begin testing the use of space for commercial applications such as navigation, communication, and Earth observation. 2. Continue with the supersonic and hypersonic research program. And 3. Begin preparing to send an American pilot into space before the Soviet Union. 30th of September, 1958. NASA, in cooperation with the Air Force and Navy, has prepared a newly modified Aethra-2B to launch the first navigational satellite known as Navistar 1. The concept of Navistar 1 uses a signal sent by the satellite from space. When the signal is received by the it uses the known orbit of the satellite and the time it took for the signal to be received to calculate the position of the receiver. This requires more accurate clocks that must take into account the time difference for the satellites further away from the Earth and the Doppler shift as a result of the transmission being sent down. To accomplish this, an atomic clock is placed on the satellite, which provides extremely accurate time measurements by measuring the regular vibrations of cesium atoms. With the accurate time, the known orbital parameters, and the position of the satellite, the receiver is able to make accurate estimates of their position. Such a system will be more accurate than any known navigational system of the day. A system like this can be applied to air and maritime travel to help prevent ships and aircraft from getting lost and ensuring that they reach their destinations on time. They can also be used to aid in the rescue of vessels and aircraft, as search teams can use the last known location of the GPS system to help find the lost vessels. This would all be great if Navistar 1 was able to get into the required orbit. Our first launch of Navistar, called Navistar 1A, failed to get into the required orbit and then failed to detach from the newly upgraded Aerobee kickstage. The 5th of November, 1958. We have the second attempt at the Navistar launch. While everything turns out okay with the original A-through rocket, the Aerobee, the humble, always reliable, never fails Aerobee, suffers a loss of thrust and fails to even put the Navistar satellite into orbit. The 10th of December, 1958, the final launch of the year. Navistar 1 finally makes it into orbit. A ship, positioned in the center of the Atlantic Ocean, makes the first positional measurements using a satellite. This actually beats the first real navigational satellite by a little under 2 years. The first real successful navigation satellite wasn't launched until April of 1960, and the first attempt was in September of 1959.